Welcome, this is Physics 2212 Lab 4, Bar Magnets by myself, Ryan Perella. The purpose of this lab is to determine the distance dependence of a magnetic field from a powerful bar magnet. The calculations measured the magnetic field when the magnet was both on and off the axis using the Biot-Savart law for magnetic fields. And then I also compared the measured and simulated magnetic fields. So the measured results of our experiment and then a computer simulation using numbers. Here is a preview of the results. 1, the magnitude of the magnetic field increases as distance decreases. 2, the off-axis magnetic field was measured to be 5.6 times 10 to the negative fifth, and the off-axis magnetic field was simulated to be 3.5 times 10 to the negative fifth. Now, the key concepts used in this lab are the Biot-Savart law, which relates the magnetic field produced by an object to the current running through the object, and the distance between the objects and the source, and that is dB equals Km times the current, dl times x, and then magnitude r squared times r hat. The magnetic field of a dipole is B dipole equals Km 2u r to the third. The magnetic field due to a bar magnet, which is B bar equals K, and then R raised to the nth, where K is a combination magnetic constant. The magnetic dipole caused magnetic field is B equals Km divided by R cubed, and then multiplied by 3 U times R, multiplied by R, subtracting U. And the distance dependent formula is the natural log of B equals natural log of L plus N times the natural log of R. So a lot of formulas there, but we mainly use number 4. Here is a picture of me doing my lab. You can see my phone set up using the ruler as a axis marker, and then the magnet on the same axis for this picture as my phone. And here's a screenshot I took of the data I got off of my phone using my phone in order to measure magnets and use my phone as the data collector. Before we get into the lab, the systems and surroundings. The system is the observation point, my phone. The surroundings are the bar magnet and everything else, and we treat the bar magnet as a magnetic dipole. The setup, we have 2 different setups. One where the magnetometer was off-axis as the phone and the magnet, and then this measured the strength of the field at different distances, and we apply that in Excel. And another where my phone is lined up perpendicular in order to cancel out the Earth's magnetic field. That is the image you saw earlier. Here is where my group plotted my group's data, which was taken from multiple results of the experiment, and then using the Excel sheet and the formula calculators that were given to us, we put in the data and then made the graph. Here you can see the off-axis data. Notice the bottom right corner. That is the net that I showed in the preview of the results. Here's some screenshots of my code. Using the starter code, this is very easy to do. Just plugged in the formulas that was shown earlier, and then it made that image you see in the top right corner, and you can see the arrows pointing in the direction of magnetic fields. Now, my observed results, which was taken from the data I collected and then using the Excel sheet, we observed and measured that the B net was 5.6 times 10 to the negative fifth, whereas the computational results from my coding, we saw that B net equals 3.5 times 10 to the negative fifth, which is a little off, and we'll get into why that could be off. Now, potential errors that could result in that big difference in my simulated versus measured data is that we assume the bar magnet acts as a magnetic dipole, which could be true, but it's probably not the exact case. Other objects nearby, such as electronics or other magnets on the table, definitely could have skewed the data, such as my computer being on the table in order to read the lab procedure. The exact location was not found precisely, and then that goes into the fact that my phone is not a widely accepted scientific instrument. It doesn't have the best data in terms of location and sensing magnetic field. So it does its best, but it's not professional. And some things to take note of were that I observed that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And then as the magnetometer moves closer, the measured x component of the magnetic field increases. I found on my phone that you had to take the magnitude because sometimes it was negative. Not sure if that was my phone being flipped upside down though. Now, what if I hadn't oriented the experiment to compensate for the magnetic north and south? Well, that would mean the Earth's magnetic field would then interfere with the bar magnet and my phone, and then the results would be very different. What if we were to stick two identical magnets together end to end? Well, the magnetic field would then double, theoretically, but the direction should stay the same. So those are the what if questions. Thank you for watching. Have a good week.